Hello everybody, this is Biswajoy Chatterjee. I'm the Vice-Chancellor of University of Engineering and Management, UEM, Jaipur. And today I'm over here with the next puzzle, and this one reads as the missing number puzzle. So what is it? The thing is that we will be putting forward a list. Say this is the list. And it says each number will appear once, one number will be missing in between. You need to tell me which number is missing. Say if this is the list, which number is missing over here? Is it at all difficult to tell me that within this given list, which number is missing? Yes, you all know it very well that the missing number is 6. Yes, it's 6. But if the list is bigger, say I give you another list. This is the list. Which number is missing over here? See, as I said, each number will appear once and which number will be missing in between. Like in the previous case, you saw 1 was there, 2 was there, 3 was there, 4 was there, 5 was there, 6 was not there, 7 was there, 8 was there. So in between a number which is missing was 6. 6 was missing. Like over here, which in this list, which number is missing? As you can very quickly find out again, see 1 is present, 2 is present, 3 present, 4 present, 5 is present, 6 is present, 7 is present, and so on. Say 8 is present, 9 is also present over here, 10 is present. If you look at 11, 11 is not present. So all of you can understand immediately, yes, it's 11. But how did you find it? Can you kindly pause for a second over here? You can pause the video for a second and think how you actually did it. And you will not really get an answer how you did it very quickly. But believe me, your brain is so sound, it is so quick that very quickly you went through the list many a times. You went through the list very quickly. You very quickly scanned the list once and found out that 1 is present. Again, very quickly you found out, you scanned the list and found that 2 is present. Again, very quickly you scanned the list and found that 3 is present. Very quickly you scanned the list and found out that 4 is present. Similarly, you scanned the list again to find 5 is present. So 5 times already you have scanned the list to find that 1, 2, 3, 4, 5 was present. 5 are present. Similarly, you will be again scanning the list and find that 6 is present. You scan the list again and find that okay, 7 is present. You scan the list again and find that okay, 8 is present. You scan the list again and find that 9 is present, 10 is present. Similarly, you scan again. So already 10 times you have scanned. Now you go to scan and find that okay, 11 is not present, and you say that the missing number is 11, because after that 12 again is present, 13 is present, 14 is present, 15 is present. So only 11 is not present. So do you notice one thing? Very quickly, not even you realizing, your brain had scanned this list at least 11 times or 12 times to find that 11 is the number which is missing. Now, if I give you certain constraints in this, say I give you this constraint that number 1, you can scan the numbers only in one direction and one number only once, that is only one unidirectional scan. If you remember, I was saying that you are scanning the list many a times. Here if I give you this constraint, that one unidirectional scan, see what I'm writing, one unidirectional scan is allowed. I'm writing it using a pen, so it is taking a little bit of time, but this is the first constraint that is given to you. There is other constraint also. The second constraint that is given to you, this is the first constraint, one unidirectional scan. The second constraint, that is you scan the list only once, say in this direction you scan it, and only once you scan. If you remember, then you are scanning the list many a times, going from the first to the end many a times, trying to find all the numbers. Over here you are allowed only one scan through the entire list. Second constraint, you have got only 2 extra storage spaces. in which you can store only 2 extra numbers apart from the numbers given to you, and this ensures that you do it in the minimum time. Anyway, that 2 extra storage spaces or 2 extra numbers I'm talking about can be the 2 of your brain cells or maybe 2 memory cells of the computer, whether you're doing it using your brain, whether you're doing it using a computer, but only 2 extra storage spaces are allowed, and this ensures that it will take minimum time. So again, if you go about the next list, say this is the list which is given to you, don't you forget one unidirectional scan, which means you can go through this entire list only once. That is, you are finding 1, okay, 1 is present. Then you find 2, okay, 2 is present. Then you try to find 3, okay, 3 is present. Then you try to find 4, okay, 4 is present. Then you try to find 5, okay, say 5 is present, and so on. You continue. You are scanning the list many a times. You are trying to scan 1, then you are trying to find 2, again scanning. You are again trying to find 3, again scanning, and so on. Here, as you can understand, 9 is absent, but for that you are actually scanning the list 9 times. You're trying to find 1 firstly, then you're trying to find 2, then you're trying to find 3, then you're trying to find 4, then you're trying to find 5, then 6, and so on. You're trying to find the list, scan the list many a times. What if you are given that constraint now, which I talked about? Yes, 9 is the answer, but more important than the answer is how you find it in the smallest time. One and only one unidirectional scan. I repeat that thing once more. One and only one unidirectional scan through the list, and only 2 extra spaces given to you. How to go about it? How you can do it? Only one scan and tell me, say 16, 7. How by only scanning the list once you tell me that 9 is absent in this list? See how to do it. The 2 extra spaces I was talking about, one is this max, the other is the sum. At any point of time, when I'm scanning the list, I will put the maximum found till now in the max variable and the sum of the numbers till now in the sum variable. What I mean to say is, say when I'm scanning 16, you consider this, say suppose you scan 16. When you scan 16, your max will be 16 and your sum will be 16. Then when you scan 7, till now the max, you compare that max is containing 16 and you are scanning 7. So till now the maximum is 16 itself. So max will remain 16, but the sum will become 16 plus 7, 23. Then you scan the next number 5. You are scanning one by one and only once, 5. So max contains 16 till now, 5. So which one is greater, 16 or 5? Definitely 16 is greater, so max will remain 16. I repeat once more. Say 16 you scan. So your max becomes 16. I'm writing here. Your max becomes 16 and your sum becomes 16. But then when you scan the next number, say you scan 7. So out of till now max is 16 and you are scanning 7. So who is max till now? 16. So max remains 16. But sum from 16 it becomes 23 because 16 plus 7 makes it 23. Next you scan 5. So out of 16 and 5, 16 is still the maximum. So max remains 16. The sum becomes 28. The sum becomes from 23 plus 5 makes it 28. Next you scan 14. So your max still remains 16 because out of 16 and 14, 16 is bigger. But your sum becomes 28 plus 14, which is 42. The sum becomes 42. Next you scan 11. Out of 16 and 11, 16 is still bigger. So your max remains 16, but your sum becomes 53. And so on you continue. Remember, in this way, you will keep on adding. That is 54. Sum will keep on becoming 54 firstly, then 66, then 70, then 85. And up to this, max will remain 16. Because 1, 12, 4, 15, out of this, still 16 is bigger. Then you scan 19. But remember, out of 16 and 19, 19 is bigger. So your max will change from 16 and become 19. And at that time, your sum was 85. So that will become 104. So let me go through it once now. See, you are scanning 16. Max is 16, sum is 16. Check this. Max is 16, sum is 16. Next you scan 7. See this, you're scanning 7 over here. You're scanning 7. Max is still 16. Sum is 23. Okay, forget about this. Forget about this. I cross this out. Okay, so still max is 16, sum is 16 plus 7, 23. Next you scan what? 5. So max is 16 still, because out of 16 and 5, 16 is bigger. Sum is 28. Next 14 you scan. Here you scan 14. Max is 16, sum is 28 plus 14, 42. Next 11, so max will remain 16, sum will become 42 plus 11, which is 53. Okay, so you scan 11. See, max is 16, sum is 53. Next you scan 1. So max is 16, sum is 54. So see, 12 scanned again, max is still 16, sum is 54 plus 12, 66. Next comes 4. So this time max will remain 16, sum will become 70. See this. Yes, 4 is scanned, max is 16, sum is 70. And so on. 15. So max is 16, sum is 85. Next 19. So max becomes 19 now, sum is 104. You keep on doing this. See, 1907, 1920, 1926. Next it will become 19 and 134, because max is still 19. 1934, 1952, 1969, 1979, 1981, and so on. So till now you find the max number you have found till now is 19 at the end of the list, and the sum you have got till now is 181. Your list scanning is over. As your list scanning is over, what is the maximum number you have found? The maximum number you have found is 19. You have found the max as 19. See, is not so? But you know one thing, that means had 1 to 19, 1 to 19, all numbers if would have been present. That is, from 1 to 19, all numbers if they were present, then the sum definitely would have been n into n plus 1 by 2, because you know that the sum of all numbers from 1 to n is n into n plus 1 by 2, our class 11 12 knowledge. That sum of all numbers from n 1 to n is n into n plus 1 by 2. So n into n plus 1 by 2. That is, if 1 to 19 all numbers would have been present, the sum should have been 19 into 19 plus 1. What is that? 19 plus 1 is 20. So 19 into 19 plus 1, 19 into 20 by 2. And what is that? 19 into 20 by 2 is 19 into 10. So what is that? It is 190. So if it is 190, then if 1 to 19 all numbers would have been present, the sum should have been 190. But the sum is not 190. Remember, the sum is 181. So which number is missing? Definitely 119, which should have been the sum, and 181, which is actually the sum. If you find out the difference, then 190 minus 181, that is the missing number, definitely is how much? It is 9. The missing number is 9. So how did you find it? The find out way out is max into 19 in our example, 19 into 19 plus 1, max plus 1 by 2. So max into max plus 1 by 2, 19 into 19 plus 1 by 2, 190, minus the sum. So see, minus the sum, that's the general formula. Max into max plus 1 by 2 minus the sum, that is 19 into 20 by 2, which is 190, minus 81, that is 190 minus 181. 9 is the absent number. So you know that 9 is the missing number. So thank you. It ends over here, but the job starts for the programmers, or the programmers can appreciate that, yes, you might say that what is the necessity of doing all this? You could have done you found out the missing number so easily. But yes, you are scanning so many times. Say for this a particular example, in the previous example, up to 19 means ideally you needed to scan the list 1 time for finding 1, 2 times for finding 2, 3 times for finding 3, and so on, 19 times for finding the last number. In this example, you will have to find up to, at least you have to scan 9 times. But here, in the way I have shown, you have scanned the list only once, and you know that the computer programmers will be very happy over here because they know that this list needs to be scanned only one time. Job starts for the programmers. I'll request the programmers now to write the program, scan a list, use C language, Java, Python, whichever suits you, scan a list from the user and quickly find out the list through one unidirectional scan and tell the programmers the missing number. So that's the job for the programmers. Thank you so much. Thank you from Biswajoy Chatterjee, Vice-Chancellor, University of Engineering and Management, UEM, Jaipur.